Okay, so today we want to talk about trigonometry. I don't know how much you know about this before. So the topic is trigonometry. I want to make it more complete. It is trigonometry. Because the more advanced trigonometry, you will start learning it from Math 3C onwards. But there is another traditional trigonometry that starts with the right angle triangle. Yes?
Yes, so we will learn about cosine.
Yes. Yeah, but not very advanced ones. Okay, so this is good news actually for this stressful time. So trigonometry, yes. So in right angle triangle. So this, I emphasize this. Let me put it in brackets. In right angle.
It doesn't work for anything.
It does. It's a little bit more complicated.
In right angled triangles. Okay, so I would actually teach two sections together. Okay, so in the book, one section is related to what we call tangent of an angle, and the next section is about what we call sine and cosine of an angle. Okay, but I don't think we need to separate them. It's not that hard. We can just start talking about them together. Okay, so here assume that you have a right angle triangle. So it's very important. All what I'm saying here works only in a right angle triangle. Okay. Okay. So that's in a wrong direction for me. But now let me write it. So here, assume that I have a right angle triangle. So let me try to make it complete. Okay, so something like this. And this is a 90-degree angle. So let me call it, for example, capital A. And then I can call the other vertex or corner, you say, B, and the other one C. Okay? So you know that one of the angles in a right angle triangle is equal to 90 degrees. Two of those angles are acute angles. Yes, it means that they are between 0. Yes, they are between 0. Yes, between 0 and 90 degrees. Okay, so assume that I take one of these. Before doing that, let me just mention that you remember I told you that in geometry, if I call this vertex capital A, the length opposite to that is usually denoted by the lowercase letter a. And if I call this capital B, the length of this side is denoted by little b, and for this, we call it little c. Okay, now let us concentrate on one of these acute angles, either B or C. For example, let me just concentrate on this angle B. And then I can talk about sine of B. So you write sine. If you want to write the complete name, it is sine, cosine, and tangent. But we just take the first three letters. Okay, so sine B is defined to be the opposite side to B divided by the hypotenuse. Okay, so this is my angle. There is an opposite side to this, which is B. So this becomes B, divided by the length of the hypotenuse, yes? So what is the hypotenuse here? In this case is A. How should I know? Because that is the side opposite to the 90-degree angle. So this becomes B over A. So as simple as that. So that's not something mysterious, yes? So if I ask you what is the sine of this angle, you would tell me that let me measure the length of this AC, let me measure the length of the hypotenuse, and then I divide the length of this one by the length of the hypotenuse, I get a number. That number is called the sine of B. Is that clear? That's just the definition. And I can also ask about cosine of the angle B. Okay? Then, if I want to know what is the meaning of the cosine of the angle B, it tells you that take the adjacent side to B. This is a little bit confusing. You need to understand that. So you see, this is my angle. This is my angle B. It seems that I have two adjacent sides. That's correct. This side is adjacent to this B. This side is also adjacent. But for this one, we have another name. We call it hypotenuse. So when I say adjacent, I mean this one. Yes? So you take the adjacent one, which is C, and again divide it by hypotenuse. Okay? You get a number. That number is called the cosine of your angle B. Yes? And then for tangent, what you do, you divide the opposite one to the adjacent one. Yes? So the opposite one is B. Which one of these two is called the adjacent?
C.
C, not A. A has another name. Yes? So you see that I get some numbers. These numbers are called sine, cosine, and tangent of that acute angle. Yes? So if I want to write it, you can write it in this way to remember. Sine is equal to the opposite. Let me write it in this way. OPP for opposite, divided, for example, let me write it in this way, hypotenuse. So sine is equal is not a good word, so you need to write dot semicolon equal. So it means that this is defined to be equal. That is not something that we can get.
Your tangent is wrong. It should be over.
Oh, thank you very much. I told you the opposite divided by the adjacent one. Thank you very much. Adjacent one is C. Thank you. And the cosine is defined to be what? Cosine is called the adjacent one. Let me write ADJ for adjacent, divided by the hypotenuse. And the tangent is defined to be the opposite divided by the adjacent. So this I don't remember actually if this is given in the formula sheet or not, but I think it's very, very important to have it in your memory. So if you want to calculate the sine of an acute angle, I emphasize again, only acute angle. I cannot talk about sine of 90 degrees here. You might ask, okay, I take my calculator, I get a number for sine of 90. How I get this one? You need to wait a little bit until the next lesson. Not this year, next year. So, if I have a right angle triangle, I have two acute angles. I can talk about sine, cosine, and tangent of those two acute angles. If I am interested in sine of an acute angle, I divide the opposite side by the hypotenuse. It gives me a number. That is called the sine of B. And then, if I want to calculate cosine of B, I divide the adjacent one by the hypotenuse. It gives me a number. That number is the cosine of B. And if I am interested in calculating tangent of B, what I need to do, I need to divide the opposite one by adjacent one. So these are the rules. For example, so these are my rules. If I ask you here, let us talk about this, sine of C. Let us talk about cosine of angle C. Let me talk about tangent of angle C. Okay, so let us fill it up. So what do you think sine of C would be? Let us read the definition. It is opposite divided by the hypotenuse. If this is my angle, acute angle, sine is the opposite one divided by the hypotenuse. Opposite to this one is angle C. Yes, is the side C. Divided by the hypotenuse is A. If I ask you what is cosine of this angle, you would say that let me find the adjacent one. There are two sides adjacent to this, but this has a particular name for itself. It's called hypotenuse. So when I say adjacent, I don't mean A, I mean B. So this becomes B divided by hypotenuse, which is A. And then finally, if I ask you what is tangent of C, you would say it is the opposite one divided by the adjacent one. The opposite one is C. The adjacent one is not A, is B. Yes? And of course, you can immediately discover a nice pattern here. For example, you see that BA, B over A is sine of B. On the other hand, it is cosine of C as well. So it is not a coincidence. I don't want to talk about these things that much. If we have time, I can talk a little bit about that. But this is not a coincidence. If I have two angles whose sum is equal to 90 degrees, this is always the case. Sine of one angle becomes equal to the cosine of the other angle. I don't want to talk about these things that much because might be we don't have time. Many things to do before this Christmas. So this is why, but you can see it immediately in this pattern. You see, sine of B is B over A, but B over A also appears in this list, and this is cosine of C. So sine of B is equal to cosine of C, and the other way around. Sine of C is C over A, and C over A also appears in this list. So it means that sine of C is equal to cosine of B. Okay, so these are the definitions, and it is very important to remember that these are only for acute angles. Of course, and then of course it is very important to know that there are buttons on your calculator. So I don't know if you have your calculator, it's better just see it right now. There are different modes for trigonometry. The most famous one is called radians. We will talk about that in Math 4. But here in Math 3C, you work with degrees. So angles are measured in units of degrees, okay? Yes?
If you start calculus
Yes?
in Math 3
Yes?
and don't talk about radians until Math 4, how do you do the derivative of trig functions? Because you need radians.
We don't have the derivative of trig functions. The derivative of trig functions appear, unfortunately, in Math 4.
Ah.
Yeah. So they have only polynomial functions and exponential functions. Yeah. Okay, so you see you need to find those buttons on your calculator, and I want you to take sine, turn it on. I want to make sure that you are in the degree mode. So you will just write, I don't know, sine of 90 degrees. If it turns you 1, it means that you are in the correct mode. If you get something except 1, it's not wrong, it's in another unit, which we don't want to use. So, okay, check your calculator. Sine, of course, sine, or you can write tangent 45. Tangent 45 is also equal to 1. Okay, so is that working for everyone? So sine 90 should be 1. Make sure that when you are doing the exam, accidentally your calculator is not switched to the radian mode. And for example, for this calculator, it is on top of that, it is written DEG. So it means that I can immediately see that this is in degree mode. Okay, so be careful about that when you are doing exam, because you will get all the answers wrong. Okay? So it should be in degree mode. And the good check for this is that calculate sine of 90, it should return 1. It's always good to check. Okay. So now let us see. But of course, by the way, let me tell you something here, because you see that, by the way, if you put those numbers in the calculator immediately gives you answer. But do you think that the calculator in the CPU of the calculator, it draws a triangular, measure these two, divide by together, and give you the answer? No. So how it's completely clear? No. The answer should be no. Yes, but the calculator is capable of giving you the answers immediately. Wow. So there should be another way to calculate these things. And that's the case, as Cameron said, that would be called calculus. So the whole point of calculus is to be able to calculate these things very precisely, okay, by using other methods. So by no means the calculator is drawing a triangle and measure the sides and divide them. No, okay. But the number that the calculator provides is exactly this number if you really draw a right angle triangle. For example, if assume that I ask the calculator to calculate sine of 30 for me, okay, or 32 for me, it gives me an answer. Okay, if I draw a triangular whose one of the angles is 32 and I can precisely measure these sides and divide them together, yes, this would be exactly the answer that the calculator provides. But the method that the calculator calculates these are not drawing pictures and figures. Yes?
When does the unit circle come up? Is that
It's matrici. Yeah. Okay, so is that clear? Let me just now try to give you some examples. So for these problems you have to have your calculator with you. Okay, so let me try to give you some flavor of the type of problems that you can solve. So example. So find x, okay? So let me make it simple so that I don't need to waste time. So a right angle triangle is given to you. In each case we want to find x. This angle is given to be 90. And this angle is given to be 30 degrees, and this is given to be 25, and this is given to be x. I want to find this x. By the way, I want you to understand that this is a completely new problem. Pythagoras Theorem is not capable of answering this to you. Yes? Because I have the hypotenuse, one of these sides is missing, yes, that's correct. But I don't have the length of the other one. If I had the length of the other one, I could use the Pythagoras theorem, find it. But instead of that, I have an angle of that given to me. So I need to use it to find that x. Whenever this kind of questions happens, that you have sides and angles involved, the problem is usually trigonometry. Okay? And then this is something I have seen students make trial and error. Be careful not to do that because that's a waste of time. Which one of these are called, by the way, trigonometric ratios. Yes, trigonometric, I have pronounced it always wrong. So trigonometric ratios. So when I say trigonometric ratios, I mean sine, cosine, and tangent. So, if I want to solve this problem, I really don't need to do trial and error. I see that, okay, I have an angle involved. Which sides are involved with this angle? One of them is x, the other one is the hypotenuse. But x is the opposite one. So it means that I have something related to the opposite angle, to the opposite side and the hypotenuse. And if I have it in my memory in the formula sheet, which one is related to the opposite side and the hypotenuse? Sine, cosine, or tangent? Sine. It's clearly sine. So it means that the point to solve this problem is to write sine 30 is equal to the opposite side, which is x, divided by the length of the hypotenuse. Assume that everything is in centimeters. Okay? The point is that this part is done with your calculator. So you need to punch this in your calculator. Sine of 30 degrees. And then if you do this in your calculator, because some of the angles are famous, I know them in my memory, this becomes 0.5. Okay? So 0.5 is equal to x over 25. And then I want to find x, so I multiply by 25. So what happens? It becomes 25 multiplied by 0.5 is equal to x. Yes? And that's 12.5. So this means that x is 12.5 centimeters. So that is more or less the lesson, but the questions could be a little bit harder, of course. Let me draw another picture for you. And you shouldn't get confused. They can draw the right angle triangle in rotated. So assume that this is now 90, and then assume that this is given to be 4, this is given to be 30, and this is given to be x. Again, I want to find this x. So let me ask you, which one is the hypotenuse? Yes, the one which is opposite to the 90 degrees. So don't get confused. Yes, even I rotate the right angle triangle, nothing is changed. Okay, I want to calculate x. Which one of these three is useful for calculating this x in this picture? How should I realize? I would say that, okay, 30 is given to me. This 4 is the opposite one. What is this x? This x is the adjacent one. So opposite one and the adjacent one are involved for this angle. So opposite, adjacent. Which one is useful? Tangent. Yes? If you use these two, I have seen many students, for example, I don't know, they have, why they think in this way. They say that, okay, this is 30, then I calculate this is 60, and I see the question from this direction. It doesn't matter. You don't need to do these things. So you have 30 degrees. This one is clearly opposite to 30. This one, is it hypotenuse? No, hypotenuse is this one, so this would be adjacent. Opposite, adjacent. Opposite, adjacent is related to tangent. Yes? So I calculate tangent of 30, but I need to know the formula. Tangent, don't get confused. It is opposite divided by the adjacent. So the opposite is 4. The adjacent is x. And I hope that you don't have any problem in solving this. This is the part that the calculator will do for you. Okay? So, but assume that the calculator, if you calculate it, I have it in my memory. If you punch it in your calculator, if that's a Casio calculator, might be it will give you exact answer. But if you have other calculators, it gives you a lot of decimal places. Yes? Okay, it doesn't matter. But let us do it in this way. I would say that always remember this. If two fractions are equal, I told you that this multiplied by this is always equal to this multiplied by that. This is very important rule to remember. So here, this one, I can give it a denominator 1 in my head. And then I would say this one multiplied by that one is equal to 4 times 1. Yes? And then what is x? You divide by tangent of 30, so it becomes 4 divided by tangent of 30. Centimeters, okay? But of course, this is not sensible. People say, what is this one? I don't know how much this is. Then you need to put it in your calculator. So you can do it, and I do it here. So let us see if we can get the same answer. So I get 4 divided by tangent of 30 degrees equals. So what is your answer? Did you get something? Yes? 6.9, yes. So the answer is yes. X is equal to 6.9. I am not respecting significant figures here. If I want to respect significant figures, okay, I have to. Yeah, I have only one significant figure here. So anyway, let us just write 6.9 centimeters. Okay, so if you in principle you should get 6.9282033. So if that's the case, it means that you know how to calculate. Is that clear? So that is the number that we get. So it means that the length of this hypotenuse is equal to that one. Okay, so let me give you another example. What do you think here? So this is given to be 36 degrees, and then this is given to be yeah, I can just write it like this. So this is 13, but let me draw it the other way around, so at least you can see that you can have this situation as well. So this one is 90 now, and then this angle is given to be 60 degrees, and then this is given to be x, this is given to be 13. So I want to find x in this picture. Again, which one is suitable? This is the first question that you need to ask. Which one of these trigonometric ratios is suitable for this case? So you see that this is 60. Is the opposite one given? No. Or is the opposite one involved? No. So it means that the opposite one is not involved. So there's only one choice. Yes, that's the cosine. Because sine has something to do with the opposite one. Tangent also has something to do with the opposite one. So this would be probably the good choice here. So I would write cosine of 60 degrees is equal to, okay. So can you tell me, cosine is called adjacent by hypotenuse. Which one is hypotenuse? 13. The one which is opposite to 90 is the hypotenuse. And which one of these two is the adjacent one? It's clearly the x itself, yes? And then this is also one of the numbers that I have it in my memory. Cosine of 60 degrees is 1 over 2, or 0.5. Okay, but let us do it not like that. Let me just multiply everything by 13. So it means that x is equal to 13 cosine 60 degrees. Centimeter, yes? But if you want, you need to punch this in your calculator. You will get exactly 6.5, yes? So x becomes 6.5 centimeters. Yes? So you see, I gave you some examples that all of these things are involved. So now let us solve a little bit more interesting problems. Hopefully you can remember this. I have to erase it. There is no enough space to write down. So another type of question, let me write this. Example. In each case, calculate the exact value of sine of theta. This is a Greek letter called theta, cosine theta, and tangent of theta. So we are supposed to calculate the exact values here. Okay, a picture is given like this. So you have this. This is 90. I don't need to write 90. So this is 90 degrees. And then this is given to be the theta in this case. And this is 2 and this is 3. So this is the information given in the picture. And then you are supposed to calculate the exact values of sine, cosine, and tangent. Okay, so which one is the easiest one to answer in this case? Immediately it is clear. Which one? Sine, cosine, or tangent? No.
Tangent?
Tangent, yes, because this is your angle. 2 is the opposite one, opposite, and 3 is the adjacent one. So what are involved here are the opposite and the adjacent one. So what does it mean? It means that the most simplest one is tangent. So why? Because tell me, if I calculate tangent of theta, what should I write? Do you remember? You have those blue formulas, I have to erase them, but you remember. Tangent is the opposite one divided by the adjacent one. In this one, which one is the hypotenuse? By the way, if you are confused, you can do that one first. Which one of them is hypotenuse? The one. So let me write here HYP. Okay, and then I am not confused because now tangent of theta is the opposite one. It's clearly its opposite too. And then I have to divide it by the adjacent one. I am not confused because the name for this is hypotenuse, and so the name for this is trig. This is the adjacent. You keep it like this because I have asked you the exact value. If you divide it by your calculator, you get a lot of decimal places. That's an approximation. Yes? Yes? Now we have to calculate sine. The sine, the information is not given directly in the problem, yes? Because tell me, what is sine of theta? Do you remember? I wrote it here. Sine is the opposite one divided by the hypotenuse. The opposite one is still 2, but the hypotenuse is missing here. Okay, so first I have to calculate my hypotenuse. So it means that, for example, I can give it a name x, and then I want to find it first. Okay, so what should I do? I would write x to the 2. I have to use Pythagoras Theorem here now. So I have to write x to the 2 is equal to this one to the 2 plus this one to the 2. And then it becomes x squared is equal 4 plus 9. And then it becomes x squared is 13. And then x in principle is plus or minus. In algebra, if this is algebra, you have to write plus or minus. But because here it is trigonometry and it's representing the length, the negative sign is not acceptable. So this is the acceptable answer. And I always forget to give the units. Assume that the unit is 20. So you are not allowed to put this in your calculator because I want to find the exact value. So this is the exact value. Okay, and then what is sine? Sine is the opposite one divided by the hypotenuse. So the opposite one is 2, the hypotenuse is 13. Square root of 13. And by the way, there is no units for sine tangent. You cannot say centimeters or whatever because 2 is 2 centimeters. 3 is 3 centimeters. When you divide 2 centimeters by 3 centimeters, the units are gone. So this is a pure number. Okay?
Does that simplify things?
And then what is cosine theta? Can you help me to write this one as well? So cosine is, do you remember what was that? What was cosine?
Adjacent over hypotenuse.
Yeah. Adjacent over hypotenuse. Yeah, so it becomes what? Adjacent one is which one? 3. Hypotenuse we just calculated. It's a square root of 13. So that's also one type of question. But there are more interesting ones. So let us do more interesting ones. Okay, so now let me give you these kind of questions. Find x rounded to 1 decimal place. Okay, so let me write this example. These are good questions, by the way. So these were easy questions. So example, find x rounded to 1 decimal place. Rounded to 1 decimal place. Okay, so number 1. I have this picture. Be careful, by the way. This triangle is not right angle triangle. This is given something like this. and then you have this height drawn for this calculator, sorry, for this triangle. And then this is given to be 60 degrees. This is given to be 30 degrees. This is given to be 100. Everything is in centimeters, for example. And then you are supposed to find this is your x. So these type of questions, this is actually the important reason that we talk about sine, cosine, and tangent. So be careful about this point. What I told you, it's still on the board. This is trigonometry in right angle triangle. Okay? So how many right angle triangles you see here? 2. You cannot trust on your intuition, say that, okay, this is also probably right angle triangle. No. If this is going to be a right angle triangle, it has been shown explicitly there. So it means that in the big triangle, you cannot talk about sine, cosine, and tangent. But in these two triangles, the left hand one, the right hand side, yes, you want, if you want to, you can just talk about sine, cosine, and tangent. So these type of problems are actually interesting problems that we want to calculate. So now, do you have any opinion? I think it would be good if you do some calculations with you first, and then give me your opinion, okay? So let me pause the video for a while. Okay, so if I want to find this x, it is clear that I can find this part and that part and then add them together. Yes, because if you want to do something with the whole x is the side of the bigger triangle, and I don't have any information regarding that the bigger triangle is a right angle triangle, so I cannot do that. Yes?
Will there be any trigonometry questions on the test that do not include a calculator?
No. The calculator is always there. So here now I want to find, I don't know, what do you think, how do you think about the problem? So let me call this bit, I don't know, let me give it a name. For example, let me call this part y. Let me call this part z. Yes? And then let me give you these names if you want to read it next time so you can at least understand it. So let me write it triangle ABC and let me give this capital H. Okay, now here, if I can find y, if I can find z, I am done because I add them together and I am done. Yes? So here in triangle ABH, so how can I find y? You see, the angle 60 is given, the opposite one is given, the adjacent one is also given. So which one is useful, sine, cosine, or tangent? Hello?
Hi.
Which one is suitable for finding y? Yes? Tangent. So I would write tangent of 60 degrees is equal to the opposite one, which is 100, divided by y. Let me teach you some trick. It's not that hard. You can always interchange these two if you want to. Yes? In principle, you should do it in 2 steps, but that's not hard. I can take y up there and take tangent below there. Okay, but let us understand why. Let us do it once. If I have A over B equals to C over D, if you want to, you can interchange the extremes. You can also interchange the means without changing the equality. Okay, so if you want to, I can put D on top. I can put A in here, and then I will not change these two. This is also possible. Let us check, by the way. Do you agree that 2/3 is equal to 4 over 6? Yes, these two are equal. But now let us interchange these two. This goes there, it becomes 6 over 3. This goes in the bottom, it becomes 4 over 2. Are they still equal?
Yes.
Yes. Okay? So they are not the same number, I agree. This is 2/3. This number is not 2/3 anymore. It is 3. It is 2. But equality is still valid. If you don't like it, okay, so I see question marks. Okay. If you don't like it, you can do it like this. You can multiply everything by y, it becomes y tangent of 60 degrees is equal to 100. And then I want to make my unknown alone. So what should I do? I divide by this to get rid of that, and I get that one. So if you want, you can do it in 2 steps. If you understand it quite well, you really don't need to bother to write this for me in the exam. You can just use it. But be careful. I have seen many people just want to do this randomly, that they will lose the points for nothing. So this is the proper way of doing that. This is a quick way of doing that. Okay, anyway. So whatever you do, this is your y in centimeters. If you want to, you can just put it in the calculator right now. But let us keep it. And then I want to do the same thing to find z. So which one is suitable for finding z? Which one? It is clear that z is in this triangle. So I need to mention my triangle. Triangle ACH. Tangent, sine, or cosine? Which one you choose? Tangent again, because opposite one and the adjacent one are the ones involved, yes? So tangent of 30 degrees becomes equal to the opposite one, 100, divided by z. For the same reason, z becomes equal to 100 divided by tangent of 30 degrees, centimeters. And then x is equal to y plus z. Agree? X from here to here is x plus y plus z. Then you can put these numbers in your calculator. And if you want to keep the exact values, you need to write it in a very fancy way like this. But this is useless usually because it doesn't give us information about the size of this. Okay, so you need to put this in your calculator. I want you to do this. Put this in your calculator, put this in your calculator, add them, and keep only one decimal place. I want to make sure that you can do it. Let me just do it here. If you have a little bit more advanced calculator, you can punch everything in the calculator and at the end press the equality button, okay? Then it is better. Because if you do some approximations here, when you want to add them, the approximations, the errors are accumulating. Yes, they are going on top of each other. So I would myself, if I want to do it, I would punch the whole expression in the calculator and then press the execution. Yes? But of course, I know that is a little bit harder. Okay, so it depends. So you need to also improve your skills to work with the calculator. So divided by tangent of... Yeah, please do the calculation. I want to make sure that you understand how to do this. 60 plus 100.
Now I actually need a calculator.
Tangent 30.
I really don't get it. I do logic equations, I don't like.
Okay, what did you get? Yeah, 230.9. So the answer is 230.9.
That's why I need a calculator, I guess.
Or a calculator.
This is very important for me. Make sure, because the hard part in principle are writing these things. The easy part is calculating. But if you make mistakes with your calculator, you will get strange numbers. Okay, another one. So let me give you another one. So let me draw 2 or 3 more here and wait for you, okay? So number 2.
Du kan aktualisera när du skriver så här x är lika med y plus z är lika med...
Nej, men eftersom vi kalkylerar hela så är det på om man skriver ihop och sen bara kalkylerar och sen skriver
komplicerat. Jag lär mig alltså alla.
Yeah, this is also a nice question.
Alltså, det skulle ta en massa tid. Alltså, om du orkar stå ut med det liksom, då är jag med på det.
Orkar du hålla på?
Alltså orkar du efter liksom.
I en säng?
Nej, jag säger inte att du skulle, vet att du inte skulle orka.
Alltså, Arocco har ju standard. Hur länge kör du?
This one,
Men nu snackar vi inte om det.
and finally this one. And so if you didn't finish it on time, you can work at it, work on it at home. And please follow what I write on the school stuff so that you know what to study, which problems to do.
Det kan vara lite jobbigt om du försöker.
I will continue this, of course. This is an important lesson. I will continue on Monday as well.
Alltså det är inte att jag
Just det, jag har den
Okay, 3 more problems for you. I want to pause the video so that you can work. Okay, so that's very important to realize. Yes? So the strategy is to calculate this bigger one. Let me call it y. Yes? And then calculate this a small one. Let me call it z. And this time subtract it. So the idea is the same. Okay? So how can I calculate z? I would write tangent of 60 is equal to this one, 85, divided by z. I want to find z, very simple. Z is 85 divided by tangent of 60 centimeters. So I am done with z. The last thing I need to put in calculator. And then I go to the bigger triangle. I am not allowed to use this triangle. This is not right angle triangle. This bigger one is right angle. So I would write tangent of 30 is equal to 85 divided by y. So this means that y is 85 divided by tangent of 30 centimeters. Yes, is that understandable? Then I subtract them. So x becomes the big one, y, minus the small one, z. You need to punch it in your calculator. I don't know, whatever you get at the end. So I have to check that your answer. So I get a y, which is 85 divided by tangent of where is tangent button? Okay, tangent of what was that? The bigger one is y, 30. Yes. And then minus, which one is that? 85 again, divided by a tangent of, which one is that? 60. So it is 98.1. Good.
What?
So, 0.1, yes. So 98.1 centimeters. So make sure that you understand this problem. We don't have that much time to explain more, but I will focus on this subject again on Monday. And please read what I write on the school stuff to know which pages you need to study, which problems you need to work on. Okay? So hopefully, if you didn't understand this problem, it went fast. Ask me again on Monday. Okay? Have a nice weekend.
Can't we have a line between the... No, so it's triangle. Yeah.
You want to draw a perpendicular line?
Yeah.
Something like this, you mean?
Yeah.
I am not saying no, because I have to see your solution. Yes, if you do this, at least this is the right angle triangle, but I don't think it will help, because here I have 30, here is this x, but I don't know this one, I don't know that one.
Okay.
The reason is that might be you can find some way to find one of these and then use it.
Vi kollar bara om vi gjorde rätt.